In this video, we are going to solve some problems based on work done and kinetic energy. A box is pulled across a smooth surface with a force F as shown below. The force F is equal to 20 Newton and is applied at an angle of 30 degrees. So we have got the force 20 Newton and the angle is given as 30 degree. It's asking us to calculate the power used by the box to move a horizontal distance. So power is missing. And the distance is given as 10 meter and the time is given to us as 5 seconds. Now, if you look at the formula sheet, the power formula is work done over time, W over T, but we don't have the work done. So we'll use the formula for work done, which is Ft cosine theta, to find the work done first. Now, F is 20, D is 10 and theta is 30. So we can substitute that into the equation and get the work done as 173 joules. Then we'll put this into power formula and get the value for power, which is 34.6 and the unit is watts. Next problem, a 5 kg box initially at rest. So the mass is given as 5 kg. It's initially at rest, that means Vi is equal to 0. It moves through 0.50 meter, so distance is given as 0.50. The net force acting on it is 40 Newton and is asking us to find what's the final speed. Now, work done also has a formula which is change in kinetic energy, which we can write it as half mvf square minus vi square. So here we are not going to use Fd cosine theta. Instead, we have to use the formula for velocity. But if you see, we don't have the work done again. That means we have to again go back to our first formula, which is Fd cosine theta, because we want to calculate what's the work done. So for finding the work done, we have the force and the distance, but the angle is missing. So if you look at the diagram, the force is towards the right and the displacement or the distance with which the box is moved is also towards the right. That means the angle will be equal to 0 because force and displacement both are in the same direction. Now we use the formula Fd cosine theta to get the work done, and we get the answer for work done as 20 joules. This 20 joules we will put in the first formula, which is half mvf square minus vi square. Work done is 20, then half times mass is 5, Vf we don't know, and Vi, because it was at rest, is 0. We can solve it to get the value of Vf, which is 2.82 meter per second. Next problem. A car of mass 1500 kg starts from rest. So the mass is 1500 kg. It starts from rest. That means Vi is equal to 0. It reaches a velocity of 22 meter per second. So that's our final velocity, Vf. In absence of frictional forces, what is the work done to change its velocity? So we want to find what's the work done. Now in this problem, they have given us what is Vf, what is Vi and the mass. And they are not telling us what's the force, what's the distance involved. That means the formula which we will use from the formula sheet is W equal half m Vf square minus Vi square. So you can see that the first formula Fd cosine theta will not be used here because we don't know what is F, we don't know what is D. But we know what is Vf, Vi and mass. So we use the formula half m Vf square minus Vi square, substitute the numbers into it, and we will get the answer. Do not forget to put the unit, which is joules. Next problem. A cyclist and cycle have a combined mass of 80 kg. So mass is given as 80 kg. He rides with a speed of 12 meter per second. How much work should be done by the brakes to bring the bike and the rider to a stop? Stop means the final velocity will be equal to 0. It's asking us to get the work done. The final velocity is equal to 0. Initial velocity is 12 and the mass is given to us 80. So we will use the formula half mvf square minus vi square. Substitute the numbers into it and get the work done. You can see that the work done comes out as negative 5760 joules. It is negative because we are trying to stop the bike. That's why the work done will be negative. What is the magnitude of the braking force? So you applied brakes to stop the cycle. To stop the bike. Yeah. So you applied brakes and it's asking you what's the magnitude of that force. So it traveled a distance of 4 meters. So we have the distance 4 meter. W equal to FD, that's what we are going to use. We are not using FD cosine theta because there is no angle mentioned here. And even if we want to check about the angle will be equal to 0. So it will become W equal FD. W, we can get the answer from the first part, minus 5760. Force we don't know, distance is 4. We can calculate the force to be negative 1440 Newton. So the braking force will be equal to 1440 Newton. Negative is just telling you that it's a braking force. So we can remove that negative and we can write braking force is equal to 1440 Newton. Next problem. The graph below shows a force displacement graph for an object. What is the work done by the force to move the object through 1.5 meter? Now we have got a graph here and we know that from a force displacement graph, work done is equal to area under graph. So we can find the area of the triangle. You can see that the shaded part is a triangle. Formula for area of a triangle is half base times height. Base and height is labeled in the diagram. As you can see, I have labeled it. So the base is 1.5 and the height is 20, and we can get the answer as 15 joules.